Welcome back to the Data Fishbowl, guys. We're going to look at SQL Window Functions using rank and dense rank. Now, rank differs slightly from row number. We saw that row number returned a unique number for each row starting with the number 1. But with rank, we assign a unique number for each row starting with 1, except that the rows which have duplicate values have the same ranking. And then a gap appears in the sequence for each duplicate ranking. And the only way to really understand this is by looking at an example. So let's have a look at our check payee and check amount. With row number, we saw a unique number going up for each value in that partition. Whether we're using descending or ascending values in the check amount, there's an order, and the order starts with the highest amount here because we're doing descending. So it's going down from 8820, which is the highest check amount, all the way down to whatever the lowest check amount is for that particular check payee. And each value in that check amount column is given a row number. But with rank, when you get a duplicate value, you get a ranking which is the same. So 8820 gets the same ranking as 8820 on this particular record. They are both joint position 1 there. Okay. When we get to 3920, which is the next lowest value in our order, that's position 3. And you're thinking, why is that not position 2? Because with ranking, the first 2 positions have already been taken up by position 1. And you'll see in the example that follows, it's a bit like a leaderboard in a competition. Imagine 2 people came in with exactly the same time in a time trial. They're both ranked position 1 joint winners. And then the next person is actually position 3. That's similar to what we're seeing here. The ranking of 3 is given here because the first 2 places have already been taken. And that's repeated 4 times here because 3920 occurs 4 times. And you see 3, 3, 3, 3 being put in because it's a repeated value. But when we get to 3220, that's given position 7 because the first 6 places have now all been taken. So you see gaps in the numbering when you use rank. And similarly, we see 3080 being given a value of 9 because the previous 8 have already been taken. So let's have a look at this example of a class competition. Could be any competition within a class, but for illustration, what I've done is I've divided the classes into fire, earth, and wind. And that's our partitioning, okay? So within that partition of fire, we see James, Richard, and Raj, okay? And James and Richard get 12 points each. So they're given the same ranking. Raj is given ranking of 3 because positions 1 and 2 have already been taken. Earth is fairly simple because we've got 2 distinct values in there, so they just get positions 1 and 2. When we get to this wind partition, Matthew gets 14 points, which is the highest mark, and nobody else is getting 14, so he gets position 1. Ali and Sarah have both got 12 points each, so they get joint second position there. When it comes to Craig with 9 points, the previous 3 places have already been taken, so he gets rank position 4. So you see the difference between row number, which gives a consecutive value for each individual row within the partition, even when there's a duplicate, as opposed to rank, in which you'll see gaps appear. Now there's another function that I want to just go over with you, and that is dense rank. The dense rank is slightly different to rank in that you don't see these gaps in the values. So let's have a look at an example. So when we look at our check PAYE 63, with dense rank, 8820 is joint position 1. 3920, which repeats for 4 of our records, are all position 2. So you see no gap. 3220, for both of these 2 records, is joint position 3. And 3080 ends up as position 4. There are 4 unique values, each one of them given the same dense rank value. And some people find that much easier to understand than rank. That's fine. Each has its own particular use. Normally, I find that row number is the most commonly used function when it comes to window functions. But each of these has its place. So if we now look at dense rank in the classroom example that we looked at with rank, we see that James and Richard are both joint position 1 in their class with 12 points. And Raj gets position 2 because he gets the second highest value in points. Okay. Jenny and Toby is fairly simple because they've both got different values for the points they've earned, and they get position 1 and 2. And when we get to the wind partition, Ali and Sarah there are joint position 2, and Craig gets position 3. So you don't see any gaps within a partition for the ranking value when you use dense rank. I would study this particular table and try and understand the difference between each of those 3 functions, because it illustrates exactly how each of those functions works. From my experience, I found that I use row number more often than any of the other functions, but there's a place for each of the others as well. So with rank, for example, as I mentioned, it's very similar to a leadership table on a race or a competition. Dense rank gives you a very good way of identifying the nth highest value or the nth lowest value in a list of scores. And you just have to evaluate your particular scenario when you come across the problems at work or on a particular project and apply the appropriate function in your partition. So we're back in PG Admin now. I'm going to show you the code involved in constructing your rank or your dense rank window function. It's very similar to using row number. Let's start with what we did before, which was to use the row number window function. And if we just run that particular query again, you see the row number column being added at the end. So we've used row number as the result for the row number function. So you've got row number column there. And all we really need to do is change this to rank. And we'll call the output rank as well. So if I run this, let's just reduce this output. So if we put a condition here, say where check pay is greater than 60, and that will help to reduce the dataset output that we see. Okay, that's far better, because 61 and 63 have a lot of records, so it better helps to understand the rank function. Now what are we doing here? We're applying the rank function over partition by check payee. So we're grouping the records. Our window is basically the check payee, and we're ordering by the check amount descending. Okay, and we're calling that ranking rank. Now, what do we see different between what we did for row number and what we see for rank? Well, if you remember back to the slides we just looked at, where we've got exactly the same value, there's 2050, the rank value is the same. And for 61, there are 3 records here. So the third record doesn't have rank value 2, but it has rank value 3 because the previous two positions have been taken up by the joint first position of this particular check amount. Similarly, when we look at 63, check payee 63, so this is our next partition, we see the first two values, 8820, both receive rank 1. And then the next value down is given a 3 because the first two places have already been taken up by rank 1. And 3 continues for 4 records there. And then the next value down the chain is given a rank of 7 because the previous 6 positions have been taken up, and so on. So that's like the leadership board which I spoke about in the slides. So that's rank working. Now to change it to dense rank, all you need to do is change this . We run that. So now you see the output change. So for 61 there, 2050 is given rank of 1, dense rank of 1, and the next value along, unlike rank which gave it a position of 3, rank position of 3, dense rank gives it a position of 2 because it's the second highest value. So that you see the difference between rank and dense rank playing out here. So with 63, we know the highest check value is 8,820. So that's given position 1. The next value along is 3920, and that's given position 2. So there's no break in the ranking value now. And then the next highest value is given position 3 in the dense ranking. And that exemplifies the difference between row num, rank, and dense rank. And for this particular part, that's all I want to discuss. But do look at the slides again, because there was a table in there where I gave you a comparison of all 3 of them side by side. Now I'm going to run a piece of code that will give you that now. So let's have a go at putting that all together in one statement. So if I just repeat this particular row here, and we'll change the function. So we put row num here. We'll change this to rank. So we'll call this rank. And we'll call this one row number. And let's run that, and you should see the difference side by side now. Okay, so now this is similar to the slide which I showed earlier, but you can see it with the code now. So 61 there, we see that with row number we're getting a consecutive number 1, 2, and 3. With rank, you've got the positions where the actual position is missed because the first 2 positions are taken up by the first value, and then you've got position 3 directly after that. And with dense rank, you get no gaps in the sequence at all. So that's a good way of seeing the difference between row num, rank, and dense rank. So take that code and apply it to other tables if you want to, and practice that, because the more you use it, the more you'll understand how it's used. But as I've said before, in my experience, the one I use most often is row num, because I'm usually looking for the largest value in a particular partition, or the smallest value in a particular partition, and I'm usually just looking out for the first row num value.